Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face Trending List, published on January 8, 2026, just 2 days ago. It proposes a robust framework that outperforms standard model merging and collaboration techniques by using a router to not only select the best expert model for each word, but also actively correct their predictions in real time. The paper is titled Token Level LLM Collaboration via FusionRoute. And as we'll see later, the results are really impressive, showing it can match domain experts while offering much stronger general-purpose capabilities. So, to understand the innovation here, Figure 1 compares 3 collaboration strategies side by side. At the top, we see sequence-level collaboration, where models generate entire separate responses before a final answer is synthesized, which turns out to be coarse and computationally inefficient. In the middle, previous token-level methods try to switch between models at every individual step, but this selection process becomes unstable if the chosen expert is uncertain. Finally, the bottom panel illustrates FusionRoute. Here, the router doesn't just pick a model, it actively contributes a complementary signal to refine the output token, making the process both fine-grained and robust. Well, Figure 2 details exactly how this architecture operates. The top panel illustrates the inference flow, where the router processes previous tokens and performs 2 parallel tasks. On one path, it uses a linear layer to select the most relevant expert, shown here as M1, M2, or M3. Simultaneously, it generates its own complementary logits. As the equation on the right shows, these router scores are added to the expert's scores to create the final output. The bottom panel then outlines the 2-stage training process. First, a supervised fine-tuning phase teaches the model to select experts, followed by a direct preference optimization phase that refines the combined behavior. Alright. Moving to the results, Figure 3 assesses performance on general, open-ended tasks, using GPT-4o to judge win rates against a standard fine-tuned baseline. On the left, looking at the Llama 3.8b family, most methods like DARE or task arithmetic hover near or below the 50% dashed line. However, notice the orange bar for FusionRoute. It towers over the others, exceeding a 60% win rate. The right panel confirms this trend for the Gemma 2 family, where FusionRoute again secures the highest score, showing that this token-level collaboration boosts overall quality, not just specific domain metrics. So, while Figure 3 focused on general win rates, Table 1 now details the exact performance across specific tasks. Looking at the Llama 3 family in the top section, we see the limitations of single experts. The math expert dominates the GSM 8K column, but fails elsewhere, leading to a low average. In contrast, the highlighted FusionRoute row achieves the highest average accuracy of roughly 0.57. It outperforms methods like task arithmetic and collab, while staying competitive on specialized tasks, such as human eval for coding. The bottom section confirms this robustness with the Gemma 2 family, where FusionRoute again secures the top spot. Okay, having established the overall performance, Figure 4 isolates the impact of the training pipeline. It compares the method without the preference optimization stage, shown in the light orange bars, against the full FusionRoute setup in dark orange. For the Llama 3 family on the left, we see a clear lift. The win rate jumps from around 58 to over 62%. The Gemma 2 results on the right confirm this benefit, proving that the final alignment step is crucial for helping the router effectively correct the experts. Well, Table 2 digs deeper into the architecture by isolating the effect of the complementary logits. Basically, it asks, is it enough to just route to an expert, or do we actually need that corrective signal? In the Llama 3 section, comparing the row without complementary logits to the fully highlighted FusionRoute row below it, we see the average accuracy jump from 0.52 to nearly 0.57. The gains are most dramatic on coding and instruction following, confirming that the router's ability to actively correct expert outputs is essential for performance. Wrapping up, 2 takeaways stand out. First, simple expert selection has theoretical limits, but adding a corrective signal allows the system to overcome them. Second, FusionRoute proves that efficient, specialized models can collectively outperform massive, general-purpose baselines when guided by this adaptive policy. That's it for this episode of the AI Research Roundup. I'm Alex. Thanks for listening.